Kia ora, Year 12. This is a question for Chinmay from Chapter 9 on the Poisson distribution. Okay, so it's actually straight out of the textbook. I haven't changed the numbers. Shh, don't tell anyone. We've got a few words that are different though. So we've got a book that is 500 pages long and there are 1,500 typos in total in that book, right? And we have to figure out the distribution of how many typos we'd expect to find on some different page numbers. So if you think about it, what we're saying is that in the total book, there are 1,500 typos and they're spread over 500 pages. So that means that on average, the rate of typos per page is going to be equal to 1,500 divided by the number of pages, which gives me 3. I'm just going to change pen, so 3 per page, right? So what we want to do now is basically find the probability distribution of typos per page. So we're going to think of that in our heads as some kind of bar graph. There'll be some pages with none, there'll be some with 1, some with 2, some with 3, and so on. Okay, so it's a Poisson distribution with lambda equals 3. So what we have to do first is find those probabilities and then say, well, the book is 500 pages long, so we'll times those probabilities each by 500. And once you see it like that, I think the problem is not too hard. So we know the formula for a Poisson distribution is this. It's e to the negative lambda times lambda to the x over x factorial. So that tells me that the first one, the probability that there are no typos, is going to be equal to e to the negative 3, and that works out to be 0.049787. To find the probability that x equals 1, I can either use that formula or I can use the recurrence relation, which says that it's going to be 3 times, so lambda times e to the negative 3 over 1 factorial. So that's an easy way to do it. That gives us this. And we do the same thing for the probability that x equals 2. So I'm going to use the recurrence relation again. It's going to be this last number that we got. So it's going to be 3 divided by 2 times 0.149361, which gives me 0.22404. Okay, so what have I got now? Well, I've got the probabilities for having no typos on a page, 1 typo on a page, and 2 typos on a page. But now we know the book is 500 pages long, so we're just going to take each of these numbers and times them by 500, because I was asked on how many pages I'd expect to find those. Oh, and I think I didn't do the last one, which is 3 or more typos, but that's clearly going to be all the rest of the pages. So, pages. No pages, so those will be 500 times 0.049787, which gives us 24.89 pages. We'll round that up to 25 pages. Okay, and then 1 typo, same thing, so 500 times the number, and that should give us, what does that give us for some answers? I think for 1 typo, we end up getting 75 pages. I'm doing this really fast now. And then 2 typos gives us 112. And then 3 or more will equal 500 minus 112 plus 75 plus 25. Okay, obviously, this working here is completely rubbish. So please do better working than that. This is the kind of thing we should be seeing, right? So we've got the probability here, and we're going to times it by 500, get our answer, and then round it up. So there you go. That might be the shortest video I've done all week. I hope that helps. Just email me if there are any more questions.